We are looking at figure 12.4 and 12.5 on pages 235 and 238 of your textbook. The idea here is that we know damages is caused by the amount of people that's exposed to the pollutant. So if there is a lot of people exposed to a pollutant, then the damage would be very big. However, if there's only a few people exposed to the pollutant, the damage would not be as big. So if we have a river, for example, flowing this way towards a city. Now there's a city over here with a lot of people living in the city. And there's two factories on this river, factory A and factory B. Now factory B is a distance of, let's say, 10 kilometers from the city, while city A is a distance of 20 kilometers from the city. So when factory A emits pollutants or waste material into the river, it pollutes the river over here 20 kilometers from the city. The river then has some time to work on that pollutant and to decompose it and to make it less harmful to humans. Let's say factory B emits exactly the same amount of exactly the same pollutant, but they emitted only 10 kilometers from the city. The river has less chance to break the pollutant down into less harmful pieces before it reaches the city. So even though pollutant A emits exactly the same amount as factory B, the effect of factory B is much larger than factory A because they're closer to the city and the pollutant isn't decomposed by the river fast enough before it reaches the city, where factory A, there's a lot of time before the pollutant to get worked into a less harmful substance before it reaches the city. So can you see, even though if we put the same charge for both company A and company B, it wouldn't be exactly right in the sense that factory B has a much bigger impact on the city. So then figure 12.5 tries to show that maybe we can put zones in. So let's just draw a new curve, a new diagram. If this is the river over here, flowing this way, the city is set over here somewhere. So the river runs through the city and there's people over here using the water in this river. Now there's a couple of factories polluting into this river. Let's say company A, 1, 2, 3, 4, closer to the city still, 5, 6, 7, and even after this, the city, there's even 1 or 2 more pollutants. Now the government might say, listen, the guys over here, the factories over here, even though they emit the same amount, the pollutants is not as harmful because the river has time to decompose it. This bunch over here is a bit more harmful, and number 7 is very close to the city. It harms the people in the city a lot. Number 8 maybe even have no impact because they pollute the water after the people use it. So what we can do here is we put a charge of, let's say, $50 per ton emitted by all the companies in this area, which we call zone 1. Then when we get closer to the city, we know the companies that pollute here into the river, there's not enough time for this to be broken down before it reaches the city, and it has a bigger damage to the people of the city, so we charge them $100 per ton that they emit into the river, and we call this zone 2. This company 7, we ask $150 per ton they emit, and we call that zone 3. Now this company over here can either be tax-free, meaning we don't even tax them, or we can just put a very low tax here, let's say like $10 per ton, because they do not pollute the water that's used by the city, because remember the stream is flowing this way. And that's the idea between non-uniform emissions and the idea between zoning charges.